Hello, welcome. Let's try to solve another problem. Leetcode 3290, maximum multiplication and score. So for this problem, we are giving us an array A. So the length of the array A is 4, and it is a fixed size. And for another array B, it's gonna be have a size of at least 4. Yeah. So for array B, it is the length gonna be 10 to the power 5. For array A, the length gonna be 4. It is fixed. So you need to choose 4 indices I0 to I3 from the array B such that it's gonna be in a sequence. So I0 gonna be less than I1, less than I2, and less than I3. So your score will be equal to the value of A0 times B I0, A1 times B I1, and A2 times BI2 and A3 times BI3. So the meaning is that we just need to find a sequence in array B. So for example, we're gonna choose this number 2 and this number -6 and this number maybe 4, and the last number gonna be, I don't know, let's say maybe, I don't know, maybe we're gonna choose the first number 2, so 2 times 3 times 2, and the second number -6, it's gonna be 2 times -6, and then we're gonna choose a number 4, it's gonna be 5 times 4, and for the last number we're gonna choose a 2, it's gonna be 6 times 2, and the final result is gonna be 26, and this is gonna be the maximum score you can achieve. So for this problem, actually, this is similar to a longest common subsequence problem. It means we need to choose some sequence inside array B, and we need to make the multiplication score maximum. So for each of the integers, so for array A, so for each of the integers, definitely we're gonna choose it. So for array B, we're gonna choose the sum of the integers. We're gonna choose 4 of the integers, definitely. And if the array B equals to 4, it is okay. We just need to choose those 4 integers because we only have 4 integers. Definitely we cannot use the brute force because it's gonna be n to the power of 4. Definitely it didn't work because n equals to 10 to the power 5. So this means we need to use some dynamic programming idea to solve the problem. So for number so we're gonna define 2 indices I and j. So this is I and this is j. So for the first number, we have 2 decisions. We can choose it or not choose it. So for array A, it is okay. It is only dependent on array B. If we choose this number, so definitely we're gonna use this number 2 times 3. So this is our decision. And then we're gonna move on to the next number, -6. So we can decide to choose it or not choose it. So if we choose this -6, definitely it's gonna plus a -6 times the next number, which is going to be 2. So this is the idea. So for the next number, it's going to be 4. So if we decided to choose it, definitely it's going to plus 4 times the next number. It must be 5. Now we're going to move on to the next. So for this -5, maybe it is not a good idea to choose it, so we will ignore it. So it is okay, we just ignore it. But for the indices j, it's going to be fixed. It's going to be moved to the last one. It is 6. So for -3, we will not choose it. It's not a good idea. Maybe for the next number 2, we're going to choose it. If we choose the next number 2, we're going to plus 2. It's going to times the last number, which is going to be 6. Now, how many numbers we've chosen? It is 4 numbers. It means we are ready to return the final result. It may be a possible result, and it is 26. And maybe our result is not the best, but 26 may be the best. We're going to choose 26. This is the basic idea. As you can see, this is going to be a dynamic programming idea. So for each of the number inside array B, we have 2 decisions. We can choose it or not choose it. So it's similar like the longest common subsequence problem. We can delete it or we cannot delete it. Here is that we can choose it. It means we will delete the next number. We can choose it or not choose it. It is just the same idea. So now let's just start coding. So I'm going to use a case, and I'm going to define a DFS function. Here I'm going to use function f. So I'm going to define 2 indices I and j, And finally, I'm gonna call it from 0 to 0. So the first indices means array B, and the second indices means array A. So from here, I'm gonna prepare n gonna equal to the length of the array B. Yeah. So if I the first index means array B. If I equal to n, I'm ready to return the result. So I'm gonna return 0 if j equal to 4. If j equal to 4, it means I've already chosen 4 numbers. I'm ready to return the result, which is going to be 0. Yeah. Otherwise, if j not equal to 4, but I equal to n, it means I didn't get the final result. Yeah, this means for the I, it has already goes out of the boundary. But for here, I didn't choose 4 numbers. Definitely, I cannot return the final result, right? Because I didn't choose even 4 numbers. So this means I'm gonna return a negative infinity. This is just a boundary. Now I'm gonna prepare the first result. So this is not chosen. So it's gonna be fi plus 1. It's gonna be yeah, let me think about it. So here, yeah, I will not choose it. So it's gonna be I plus 1 with j, and if j less than 4, so this means I can, yeah, so this means I can choose a number. So I'm gonna update the result. It's gonna be the maximum of the result with f. So I gonna update it to the next number, and j gonna plus 1. Yeah, we'll update it to the next number. But I need to plus the final result, which is gonna be which is gonna be bi times aj. And finally, I'm gonna return the result. Yeah, so for this result from here, so this means for this number, this I plus 1 means it is for array B, it is not for array A, otherwise you don't understand it. So j is going to be fixed. This means, for example, for this number, for the first number, it's going to be 3. I'm going to fix to this number 3. But for here, for example, this 2 is not chosen, but the index j is still at 3. Maybe I'm going to be shifted to next number. It is okay. Yeah, so this is the basic idea. So this means for any number inside array A, for example, I will not choose it. But for array B, if I not choose this number, I'm going to shift to the next. Maybe next one I can choose it. Yeah, so this is the basic idea. Now let me just run it. As you can see, it works. Now let me just submit it. Yeah, as you can see, it works, and I think the speed is okay. It is 3 seconds, but basically it's a dynamic programming problem. So the time complexity gonna be 4 times 10 to the power 5. So from here, this is the idea of not choosing, and this is the idea of choosing. So if we're gonna choose a number, we're gonna update the final result. This is why we're gonna use the bi times aj. Yeah, I think that's all about it. Thanks for watching. See you next time.